Welcome back to another part in my series on the STV CNC plasma table. So in this video, I'm going to show you some of the biggest changes I've made to this table to make it easier to work with, easier to service, easier to use, just overall more enjoyable. So I've got several major upgrades, and the first one I'm going to start with is going to be the grease ZERKS. So the way this table comes, it comes with these angled ZERKS. And they are actually a two-piece ZERK. I'm happy somebody cleared me up on this. You do not have to rip the table apart to remove these. You would first remove the head and then you would move the body. And so here's what that looks like. Here's just the ZERK, and here's the body the ZERK actually threads into. So that gives you your angled ZERK. So you're going to remove that, because the problem with this is these threads are obviously not going to be clocked. Clocking threads is an extremely difficult procedure. So that's why something like this is going to be a poor fit, because in my case, once you tighten this down, it's shoved into the metal and you can't get your grease gun on it. Or in this case over here, this ZERK is pointed straight up into the sheet metal, and there's also no physical way to get into it. So if I would loosen the ZERK this way, now the grease is going to come out past the threads of the ZERK and come out instead of going into the bearings where you want it. On our x-axis over here, we have these ZERKS. You have a ZERK here that's impossible to hit, and same thing over here. And there's no reason for these to be angled. Angling it does nothing for anything. They should just come straight out. And then lastly, on our z-axis, we have these bearing units, and these have a plug on the top, and then there's just an open hole under here on the bottom. So you can just wipe some grease on this and then run your z-axis up and down over it, or you can take the needle adapter and put it up into that hole. The best I can tell, if you do want to put a ZERK on this, it's M4 by 0.70 thread, and I am unable to find an extended length M4 ZERK. So this is what you would need. This is all I can find. The reason you would need this is to get the ZERK head down below this surface so that you can actually lock the grease gun over the ZERK, because the gap between here is too tight to get the grease gun in. So we've got two different ZERKS, two different part numbers, and I will put the link in the description for each ZERK. Now these are M6 by 1.0 thread. They are not quarter 28 like some people have shared part numbers for. If you go out and you take these out and you take the larger, I had one sitting here somewhere, if you take the larger 1/4 inch 28 ZERK and try to install that, it will not fit. And I believe these bearing housings are some type of composite or plastic. So I'm sure you could push that in hard enough and cross thread it in there. But what you really need is the proper M6 thread, which is just a little bit smaller. Now the big thing with these, okay, these only have about 5.5 millimeters of thread engagement. So the big benefit from going to this extended length unit is there's 8 millimeters of thread. And when you're talking about threading down into this plastic bearing block and you're putting a grease gun fitting on it, that's a lot of weight and a lot of leverage for a little M6 thread going into plastic. So those extra 2.5 millimeters of thread engagement make a huge difference. So now this ZERK comes out. It's probably easiest to have a hose, and I like the lock and lube. I can go till it fits. I like to hold with my thumb. I like to hold out on that, and then it locks on tight. We get a nice seal, and that one is now super simple to grease. So that's going to be the shorter. This comes in a 5-pack. Then this longer one, these come as a single unit. They are more expensive, but that length is needed because, as you can see here, the ZERK head just barely clears. And so the way this works is we're going to leave these ZERKS in. We're going to leave those alone because those are essentially sealing that side of the bearing housing off. we're going to come over here and we're going to take these plugs out. That's just an Allen head bolt. There's going to be one here where this ZERK is, and then you have one right here above the rail. And so you just take that plug out, you thread your new ZERK in, and now it's extremely easy to access. As you can see, there would be no benefit whatsoever from having an angled ZERK there. If STV watches this video, I hope they'll take these thoughts into consideration, because this is really how it should come from the factory. Easy to maintain, not difficult. Over here, this still isn't probably necessarily considered perfect because this is tight up against this rail. The lock and lube is the only thing I found that is low profile enough to slide over that. I don't like this style of ZERK grease fitting because you have to thread it on and off. And like I said, that is a lot of leverage for a little M6 thread into a plastic cavity. You're going to end up breaking that ZERK off or wobbling it back and forth before too long. So next I want to move into the software upgrades for nesting. So the first thing I'm going to show you is SheetCam. This is nesting software that's going to work a lot better than what comes with the STV table. So if you go on here, it's $279 for your license, and that should be a lifetime license. And I believe that comes with free updates as well. I've actually never tried updating my SheetCam before, but I might try it now because mine's way older than what's on this website. Now, if you're wondering, why should I go spend another $279? I already have this My MiniCAD thing. Well, this is just like extremely crude. It's kind of like Photoshop versus Paint Shop. So here I know what this gap is between the parts, that I can safely space parts without overlapping with the kerf. And this thing, okay, first of all, this program sucks to select an object. It's really hard. You have to be like right on the line. Okay, and now that I'm moving it around, see there's no like magnetic, whatever you want to call it. You have no idea, no way to measure how close those two lines are to each other right here. Also, you have to select like the whole part before you start moving it, because it's not smart enough to keep track of the fact that this piece has 3 holes on each side. So if I try to just grab the part, it totally screws the whole part up. Here's the SheetCam on the other computer. I'm being cheap right now since I haven't sold my other plasma table yet. I'm just nesting stuff over here on this computer, and then I take it over there to that computer with the thumb drive. So this is what the old version of SheetCam looks like. And so over here, you can right click, disable all. Okay, you get to set up the size of your sheet, and then you can individually activate parts. So you do have to have the right cursor selected. There's like different types. There's like, this is your start point where you would start cutting. This is the move clicker, so you do that, and then you can select which piece you want to move over here, and then you can move that part. And you just have to click anywhere inside the part, and it's smart enough, it knows that whole thing with all the holes is one piece, so it keeps it all together. If you have parts overlapped and you try to move them, it'll come up and it'll ask you, and it'll also highlight and show you. I don't really care for the differentiation and highlighting. It doesn't really change colors very well, but you select which one you want to move, like which one you're actually clicking. Okay, it's been such a long time since I've used this. Now I can't remember where that option is, but basically it's kind of like object snap, or it's like a magnet or whatever you want to call it. So it always maintains whatever gap you type in between your parts, so that once you know how much gap you have to leave between them so you don't have overlap when you're cutting with the actual plasma cutter, you can drag this over, and then there's like this barrier force field around the other part, and it doesn't let you overlap them. It always maintains that minimum gap. So when you're manually nesting, it comes in super handy. So anyway, that's sheet cam. It's 279 bucks. As you can see here, this is a lot older version. It's not perfect, but honestly, just having that that feature where you can set this minimum gap and slam your parts over is worth the 279 bucks to me, so that I'm not accidentally overlapping parts and I'm not wasting material. So once you get done there, you go up here, you run post processor, you get this tap file, save it to my thumb drive for now, since I don't have it on this computer yet. And then I come over here, go to my minicam, I go to open my thing, which here would be this file, and then this is how it comes up over here. Again, moving things around over here, really crude. You're going to want to do it in sheet cam, and you're going to want to have things exactly how you want them to be cut when you open it up over here. So the difference over here, let's say I already cut this part and I want to turn it off. I can never select that part. From what I can tell, I can never select that part and turn that part back off again. Whereas over here, you know, if I want to like take this part right here, I want to disable this part, I can always go back, turn it right back on. This guy does give you some nice stuff with like changing the sequence of where it starts cutting and all that. Like let's say I want to start in this corner, and I can come over here. It takes a minute to process, and then you see it moved. Like our starting cut is 0. That's our first cut. So that's the software side of things. I would highly recommend you get the sheet cam. It's going to make you way more productive, and it's one of the cheaper options on the market. The free options that I've seen are worth about as much as they cost, which is 0. They've been pretty terrible. I tried this one here called Deep Nest, and it was worthless. It's all automatic. It's very, very laggy, very slow, and very, I mean, it's worse than my minicam, honestly. So with the pump on the table and the ability to drain the water into the trash can every time I'm not using it, I would say within 24 to 48 hours, the stuff on the table in the bed is so dry, you can literally come in and vacuum it out. And then you can, of course, dump this into your scrap hopper and scrap all the slag. And you just get these kinds of, you can see, it's just like little BBs, like BB gun BBs. And it's super powdery and light. You can just vacuum it up. And I have 0. I've had the table going for 2 months now. 0 rusting issues. Just because I'm keeping it dry by draining the water out when I'm not using it. The next trick I have to show you is going back and putting the check valve down there at the pump that I forgot to put in when I installed everything the first time. Because what happens is you turn the pump on, you'd get the water put into your table, and then once you shut the water off, the pump off, obviously the hose is submerged in the water, so it naturally siphon itself back down through the hose into the trash can, which you can hear and maybe see it doing right now. And so we're going to put this check valve in, and that's just going to prevent water from flowing backwards back down into the trash can. So this simple little guy is a check valve for garden hose. So that's going to allow our pump to flow into the table, but not siphon it back into the trash can once I shut the pump off. You do have to make sure that you have your garden hose all the way tight to the check valve, because if there's not a perfect seal between the check valve and the garden hose end, and there's any leak at all, that'll let it still siphon. I'd also like to note how very, very, very little evaporation I've had in the 2 months that I have had this thing sitting here, all due thanks to the trash can with the lid. You can see the water is just barely below the slats, And I would argue that I've actually lost a lot more water to the ground splashing out from the torch head rather than evaporation. Which brings me to my next point, the shields. So I just got these from the fab shop. I got to finish kind of welding and forming them, but these are going to be the side shields. They're supposed to sit on here kind of like this. Now, I did order them out of way too thick of metal. I got these made out of 1/8 inch. Should have done them out of like 14 or maybe even 16 gauge. The way I had these made, laser cut, and then just cut these little horseshoes in here. And then the idea was I was just going to take like a rod and a hammer and beat these out so that they could just slide over. Well, there's a couple problems with that idea. And in hindsight, I should have just had some tabs individually made to weld on to the backside, because now I'm going to have to go in and weld a cover over this. Otherwise, water's still going to be able to get out and escape right there. So I made more work for myself than I really needed to. But if you're looking for an idea to keep the water in your table, this is definitely a great starting point. So I'm going to go get these formed and welded, and then I'll show you the final product. So here we are with the side shields installed. So this is basically the end result, but I'm still going to paint these. But I'll show you what I changed. So I had 4 tabs for our sides, and then I was going to have 3 on that one and 1 on this guy. I ended up only using tabs on the end, so 2 tabs total. And I'll show you how straight the table is not. If I can get that to focus down there in the middle, you can see it bowing out. And so if you had 4 tabs, you would have to like smash this into the table to get it to lock on. So really, 2 is plenty. All the way at the ends, I would not put your tabs in the middle. Now here's what I changed. Like I mentioned, I was going to be leaking water through here. So I just went and TIG welded my laser cut slots back shut so water doesn't leak out of there. Came up with a lot better solution, and I did this with a cutoff wheel and some scrap. So you want to find some sheet metal that's this exact thickness or just a hair more, like 10,000ths more. Put just a little tiny scab down from the tip of my finger up. That's about how tall that little scab is. You can see the ends of the welds. And then this plate on top, doesn't really matter what thickness it is. I just use the same thickness for all of it because this is nice and easy to bend. And I can just slide a piece in between here and pry this out if I need to make it easier to slide on. But the tighter you can keep that, the straighter the plate is going to stand up. So if I bent that finger out, then this would actually want to lay back that way. And that's how simple it is to slide these on and off now. So they don't keep 100% of the water in the table, but it's good enough. I mean, it's night and day better than it was. So I'll move the table over here and just show you. So let's take a look here. So we're not preventing 100% of water from splashing out. You would have to really maximize your height coming up to the track if you really wanted to save every single drop. But it's substantially better. Look at that. I really don't have a whole lot on the floor. I got a little bit, but I have one more trick up my sleeve here that should help with that part too. Now I was going to cut out a triangle and weld it to this guy on both sides, and it was going to cover up this. But honestly, after playing with this, unless you have the torch right here hovering, you're not really shooting any water out through that gap. So cut your part and move on. Don't let the torch sit there, and that makes that part not really necessary. Now these, I would absolutely, after modifying and fabbing these, I would absolutely make these out of 14 or 16 gauge. This 1/8 inch or 11 gauge is way too heavy. The perk is I don't really have to worry about them rusting out. So now with some camera magic, I will come back and show you after I get these painted. I'm going to run a bead of caulking all the way around the table except for where I marked not to caulk because the tabs have to be able to go through. But if I run a bead of caulking all the way around, even if water does splash out, now I don't have to worry about it dripping between that seam, falling into the control box, falling into the plasma cutter, or just getting on my wiring or on the floor. It'll just kind of sit up here and then it can evaporate from up there. One more thing I'm going to mention is definitely want to make sure you set up your soft stops so that you can't run the torch into your shields. So if you are thinking about doing these splash shields, super simple. You could cut them on the table yourself, clamp it to the side of a sturdy table, and that's another reason to use thinner metal, because then you can just bend it by hand. Or you can use a 2x4 or a 2x6 and clamp that to it in a couple places, and then also use that to help give you some leverage to bend it. Super simple to make the tabs. Weld those on yourself. I think this is absolutely an option that STV should be sending with their tables. Not just STV, but all table manufacturers. This was something I wanted to do on my last table, and I just never got around to it. And I really don't know why, because this was so simple. Probably didn't even take me an hour, maybe an hour and a half tops to get everything welded on and measured and trimmed to fit. All right, so we are back with the splash guards all nice and painted, and I went all the way around the table and put clear caulking all the way around. So now I don't have to worry about that water potentially dripping right here, hitting the plasma, dripping right there into the control box, or, and this has actually been a problem, water dripping right here down into my surge protector strip where I have everything plugged in. The only thing I'd really like to maybe improve on at some point would be this gap here where the water pump comes in, just because this still can splash out a little bit at times if the hose comes out of the sponge too much. Other than that, freaking love this setup. No more mess, no more spilling water every time you cut. You get the kitchen funnel on there. That also controls a lot of the water splash. Saves your eyes. Make sure you're always kind to your eyes. And now if I ever do need to slide a sheet off this side or that far side, all I do is I pull this up. I can slide the sheet on or off, pop this right back in. So definitely go out, make yourself a set of splash guards. You'll be so happy that you did. Thanks again for watching, guys. If you found this video helpful, I do all sorts of other informative videos where I show you how to modify stuff. For example, I took this woodworking downdraft table, turned this into my metal grinding and cutting downdraft table with special filters. Got the custom vise mount that I built using the CNC Sparks table. Made a welding table, made a welding cart. I do all sorts of stuff. I got one that you definitely should watch on my air compressor, dryer system, and filter system, how I ran that. Freaking love my shop airs. Took me about 2 days to build that. But again, starting to ramble on. Check my other videos out. Maybe you'll subscribe. Please like and share this video because this is a really niche thing. And I'd love to get the word out there to help other STV owners and all plasma table owners, really, because a lot of this stuff, like these splash shields, is going to apply to all tables. So, but thanks again, guys, and we'll hopefully catch you in a future video.